our wonderful listeners. So we want to round up our series on formula of compound so that all of you can understand it very well, because it's one of the major foundations in chemistry. That's why we'll continue to spend some time on it. It's one of the major foundations. Any student is able to write the correct formula will not be having much problem in writing the correct equation. And once you're able to write the correct equation, then you are good to go in chemistry. The following are some questions taken from past question paper of WAEC, NECO, and NAPTEP on formula of compound. Although in the question, students are required to use the knowledge of correct formula of the stated compound to carry out some calculation successfully. So let's use that opportunity to review the topic again from question 1 to 8. Aluminium chloride. Aluminium chloride. If you remember, aluminium chloride, I think we have done it before, or maybe it's going to be the first time you'll be exposed to it. Aluminium chloride, from the formula of aluminum chloride will be determined directly from the periodic table. If you remember, I taught you how to locate valencies of element successfully from the periodic table of the first 20 elements. So aluminium, if you check the periodic table very well, aluminium belongs to group 3 of the periodic table. So it is expected to have the valency of 3. Chlorine belongs to group 7 and is expected to have the valency of 1. So the next step is for you to exchange the valencies. The 3 that belong to aluminum will go to chlorine, and 1 that belongs to chlorine will go to aluminium. So at the end of the aluminum chloride will be expected to be AlCl3. This is the right formula, because we have been seeing students writing AlCl without putting 3 in CA test. We have been seeing students writing Al3Cl because they don't have the right foundation on how to position the valencies. Then the second one is nitrogen 1 oxide. If you remember in our previous series, I told you when you have a Roman figure given in brackets, the Roman figure or the number given in bracket overrides the valency you already know about that element in the periodic table. Normally, nitrogen is expected to have valency of 2 from the periodic table. But what you have, the 1 will not be the valency because you have 1 in bracket. So nitrogen will be having valency of 1 as given in the compound. Then oxygen normally have valency of 2 from the periodic table. 1 from nitrogen go to oxygen, 2 for oxygen go to nitrogen. Then that now becomes N2O. So that students don't be making mistake writing NO or NO2. There are reason for placing those numbers where they are. So second one is nitrogen 2 oxide. Yeah. Nitrogen 2 oxide as given in the question, you have 2 given in the brackets, meaning that nitrogen is having valency of 2, although it is also 2 on the periodic table, but you still have to work with the number given to you in the question, the valency given to you in the question. So oxygen is having valency of 2. So when they exchange their valency, the 2 cancel out. So nitrogen 2 oxide is nitrogen 2 oxide is NO. So at this stage, I expect you to begin to look at the difference between N2O and NO and why they are so. Because it is after understanding all these basic things that you can say, yes, you are moving on in the right direction in chemistry. Then you now look at nitrogen 4 oxide. Look at this series from 1, 3, 2, and 4. So as usual, nitrogen here will be expected to have the valency of 4. While oxygen will have the valency of 2. Are you getting it now? So 4 for nitrogen goes to oxygen, 2 for oxygen goes to nitrogen. So that now becomes N2O4. That that is not the final. I told you that where you can still simplify to the lowest term, you divide 2 by 2, you divide 4 by 2, and that now become NO2. So that's why anywhere around the world, nitrogen 4 oxide is NO2, nitrogen 2 oxide is NO, nitrogen 1 oxide is N2O. Please don't forget that. Then ion 3 tetrasulfate 6 are usual because you have 3 in bracket, so you expect the valency of ion in this case to be 3. Tetrasulfate 6, remember in our previous series we said tetrasulfate 6 is a radical which has the formula SO4 and it has valency of 2. It's one of the radicals we discussed in our previous class. So 3 for ion go to SO4, 2 for SO4 go to ion, so that now become Fe2SO4 because you have SO4 as a group of atom, so you put it in bracket so that 3 that is coming from ion can come outside the bracket. Because we have been seeing students writing it like Fe2SO4, they now put 3 again. And you now look as if you are writing SO43. So you must begin to write it in the right way, the way it is supposed to be written. Fe2SO43. Then ammonium tetrasulfate 6, both of them, what the two things that are combining there are radicals. Ammonium is NH4, the major positive radical you have in the positive group. Then it is having valency of 1, ammonium NH4. Then trisulfate 4 is SO3 and it's having valency of 2. So when they exchange their valencies, 1 for ammonium goes to SO3, 2 for SO3 go to ammonium. You now have it to be NH4 because 2 is coming there. We put NH4 in bracket, then the 2 can come outside the bracket here. Then SO3 go there. Then 1, don't normally write 1 down in chemistry. We have already discussed that in our previous classes. So NH4 to SO3. Then calcium trisulfate 4. For this calcium trisulfate, calcium belongs to group 2 since there's no number in the compound, so you are expected to go back to the periodic table to find the correct valency of calcium. So calcium is having valency of 2 because it belongs to group 2 of the periodic table. Trisulfate 5 is a radical, negative radical, NO3, and it's having valency of 1. So 2 for calcium will go to NO3, 1 goes to calcium, so it now becomes CaNO3 because 2 is going to the other side. You put it in bracket, then you have it 2 written outside the bracket. Then lastly, we have ammonium hydroxide. Ammonium is a positive radical, NH4, with valency of 1. Hydroxide is also a negative radical with formula OH, having valency of 1. So when the 2 combine, the 1 and 1 cancelled out. So that one becomes NH4OH. Thank you very much.